One little thing I want to talk through, a little trick. And that last question, we said it went like this. It went from a height of 10 meters. Boom. Just like that. And we cared about it when I was at a height of 5 meters. I'm not even going to color code this trick. I'm just going to show it to you. And we said, oh, you had PE here. Here's our roller coaster car as PE because it wasn't moving, it was just hanging out there. And here it had KE plus PE because it was still up in the air. Well, one little trick, we realized it really mattered the difference in heights. It didn't matter that this guy was 5 and this was 10. It fell 5 meters, okay? So one little trick, if they ever say, how fast is it going right here? You can kind of visually call that your 0 point. You're like, I'm going to treat you like you're my 0 point. And if you don't want to do this trick, totally don't do it. You can do it the way we just did it. Call that your 0 meter mark. And if you want to call it your 0 meter mark, how high is this roller coaster car starting above your 0 meter mark? In this scheme, it's 5 meters above that point, okay? And you're like, how's this gonna make life easier if I visualize that as my 0 meter mark when I'm looking for the velocity at point A right here? Well, here's why. You still start E final minus E initial equals 0 joules. You're still using the conservation energy, but the reason you call that your 0 meter mark is because you can picture I have PE, and it's going to convert over all to KE because it's going faster here. And if I treat that kind of like I'm visualizing it as my 0 meter mark, then it doesn't have any potential energy relative to this point anymore because I'm calling that my 0 meter mark, and it just makes my equation a little more simple. So my final energy is kinetic energy final. My initial was mgh initial. And you're like, okay, before I had an extra term in there because when I did it, when I called this my 0 point right here, I had to say, oh, I have potential plus kinetic at that point because this guy's still up in the air. But the nice thing about defining this as your 0 point is, then you only have kinetic energy at that point. So you're like, okay, 1/2 mv squared, v final, and really it's v final at the point A there, minus mgh initial equals 0 joules. And you do some algebra, you realize the final velocity is equal to square root of 2gh. And one little thing, super important, and I'm gonna make a little note right here. This h initial is relative to your 0 point. You just put relative to 0 point. So keep in mind, if that's, we call it 5 meters, boom, that's relative to the 0 point that you chose for this little trick, okay? So when you do this, you're like, okay, I have my h initial relative to my 0 point that I chose. And when you do that, you're like, square root of 2gh, well, it's square root of 2 times g times, well, the h relative to the 0 point I chose, I said, oh, it's 0 here, and that's 5 meters above, so I just put in 5 meters. And when you do that, you still get the same number, you get 9.9 equals VA equals the 9.9 meters per second. And if you don't want to do it that way, you can totally just do it the first way I showed you. It's just nice because when you define your 0 point like that, then you don't have to do a difference in height. So you can just say, oh, if that's 0, it's just 5 meters above my 0 point. Okay, so that's a nice little trick. If you don't like it, you don't have to do it. But the big thing is when you're saying that HI, when you're saying relative to my 0 point, then you can say, oh, it's just 5 meters above that point right there. Okay, and we'll do more of that, and it'll be good practice. All right, but doing it the longhand way, that totally works as well. So don't freak out if you're like, I don't want to define my 0 point. It's just a nice little trick to have because this has potential energy relative to this point right here. It's got 5 more meters in height. The cool thing is, in either scheme, the mass cancels. You don't even need to know the mass of the roller coaster cart. Okay, so that'll be a great place to stop.